Now we shall start Unit 2. Unit 2 is measurement of power and energy. First we will go for measurement of power. Normally we have two types of powers, DC power and AC power. Okay, so the first one is power in DC circuits. Power in DC circuits and power in AC circuits. Normally we use R load in DC circuit. Okay, so power in DC circuit will be P is equal to VI. Simply it is V into I or VL into IL. VL is the voltage across the load, IL is the current through the load. Okay, V is multiplied by I is nothing but power. Coming to the power in AC circuits, power in the AC circuits is given as P is equal to VI cos phi. These two are RMS values where cos phi is the power factor, where phi is the angle between voltage and current. Okay, in case of DC circuit there is no concept of power factor. Okay, so in AC circuit power is VI cos phi. Power in AC circuits. In AC circuits, normally we use R load, we have L load, C load, RL load, RC load, RLC loads. Okay, mostly we use RL load. Okay, so if AC circuit consisting of only R load, then what will be the power? R V is equal to Vm sin omega t. Okay, let I is the current which is flowing through this. Then I is equal to Im sin omega t. Okay, there is no phase difference between these two quantities, voltage and current. Okay, coming to the wave diagram, if this is the voltage waveform, then current waveform looks like, and which is in phase. Current waveform will be like this, and both are in phase. Okay, this is current waveform, this is voltage waveform. Okay, coming to the power, in instantaneous power, the power will be like this. Okay, this is the instantaneous power. Okay, now power P is equal to, coming to the average power, 1 by 2 pi integration 0 to 2 pi Vm sin omega t Im sin omega t d of omega t. Okay, then you are going to get P average will be equal to Vm Im by 2. Okay, this is what, this is average power. Okay, we are not interested in instantaneous power. We are interested in average power because this indicates power consumption in AC circuit. Okay, this is nothing but Vm by root 2, Im by root 2. Okay, which is equal to V into I, where this is Vrms into Irms. These two are RMS values. So in case of R load, power consumed by the circuit will be equal to Vrms into Irms, where cos phi is equal to 1 because phi is equal to 0. There is no phase angle between these two quantities. Okay. In the circuit consisting of only L load, let V is the voltage, V is equal to Vm sin omega t, I is the current which is flowing to this, let L is the inductance of this inductor. Okay, then I will be equal to Im sin of omega t minus 90 degrees. Okay, current lags voltage by an angle 90 degrees, right? Okay, coming to the wave diagram, let this is the voltage, current lags voltage by an angle 90 degrees. So current waveform starts from here. Okay, coming to the instantaneous power, okay, here this positive half is equal to negative half. Again positive half is equal to negative half. Okay, you're going to have positive half here. Okay, that is equal to this negative half, right? So average power will be equal to 0. This is instantaneous power. Okay, this is instantaneous power. The average power will be equal to 0. You can have the derivation also. P average is equal to 1 by 2 pi integration from 0 to 2 pi Vm sin omega t Im sin of omega t minus 90 degrees d of omega t. Okay, after solving this you are going to get 0. P average is equal to 0. Okay. Case 3, if the circuit consisting of only capacitance, if the AC circuit consisting of only capacitance, let V is the voltage applied across this, I is the current flowing to this. Okay, then V is equal to Vm sin omega t, then I is equal to Im sin of omega t plus 90 degrees. Okay, coming to the wave diagram, let this is the voltage, current waveform will be like this. Starts from here, starts earlier than this waveform. This is 90 degrees ahead of this waveform. Okay, then this will be the current waveform, right? Okay, coming to the power, okay, you're going to have power waveform like this. Okay, positive equal to negative, again positive equal to negative, like this. I mean, again you are going to get positive wave, positive half cycle, quarter cycle. Okay, average power becomes 0. Anyhow, this positive half is equal to negative half, positive half is equal to negative half. Okay, so average power becomes 0. Okay, average 1 by 2 pi integration from 0 to 2 pi Vm sin omega t Im sin of omega t plus 90 degrees d of omega t. After solving this, you are going to get 0. Okay, in case of R load, the power is given as V into I, Vrms into IRMS. In case of L load or C load, pure L load or pure C load, average power is 0. Average power is 0. What does it mean? That is, power consumed by the circuit is 0. That is, it doesn't consume any power. Power consumed by the circuit is 0. That means it doesn't consume any power. Pure L load doesn't consume any power. Pure C load doesn't consume any power. Okay. Now coming to RL load. In case of RL load, RC load, RLC loads. Okay, RL, RC, RLC loads. If you use any one of these three loads, the average power will be VI cos phi. Means here Vrms, IRMS cos phi. Okay. So this is lagging load, this is leading load, and this may be lagging or leading depending upon the values of L and C. Okay. Anyhow, average power will be VA cos phi. Okay. I will come back to this average power consumed by this RL load after comparison of power in DC circuits. So now first let us discuss about power in DC circuits. Okay. Power in DC circuits. Okay, power in DC circuits. We have two methods to find the power in DC circuits. First one is VA method and the next one is AV method. VA method means voltmeter ammeter method. Okay, first one is voltmeter ammeter method. Voltmeter ammeter method means VA method. You are going to find the power at this load. Let RL is the load resistance. You have to find the power at this load. First, let me connect voltmeter. Then after ammeter. Okay. Let this is supply voltage. Let V is the voltage given to this circuit. Okay. Let IL is the current flowing to this. Let VL is the voltage across this RL. You are going to find the power at this load. Okay. Then now measured power. That is power indicated by these two instruments is nothing but measured power. Measured power. That is PM is measured power, which is equal to voltmeter reading into ammeter reading. Okay, measured power is equal to voltmeter reading into ammeter reading. Okay, so what is voltmeter reading now? So PM is equal to, what is voltmeter reading? See, this gives voltage between these 2 points. Okay, let this is having some resistance. RA is the resistance of this. RA is the resistance of this ammeter. Let RA is the resistance of this ammeter. Okay, RA is the resistance of this ammeter. Okay, anyhow, IL is the current which is flowing to this ammeter, right? Okay, now IL is flowing to this and RA is the resistance of this, then there may be voltage drop across this ammeter. Let VA is the voltage drop across this ammeter. Okay, now coming to voltage reading, voltmeter reading. This voltmeter not only gives voltage across this but also voltage across this, because it measures the voltage between these 2 points. So voltage between these 2 points is nothing but voltage at this point with respect to this point plus voltage at this point with respect to this point, right? Then voltmeter reading will be equal to VA plus VL. Into what is ammeter reading? Anyhow, this directly gives the value of the current which is flowing to this RL, right? Directly gives the current which is flowing to this RL, right? So ammeter reading will be IL. So this PM is equal to VL IL plus VA into IL. Okay, what is true power? True power PT is equal to VL into IL, right? Okay, then measured power is equal to true power PT plus, okay, this can be written as IL square into RA PM, okay, because VA is nothing but IL into RA, okay, VA is nothing but IL into RA, IL into RA. So you put this in this, then you are going to get IL square into RA. Okay, so measured power is equal to true power plus power loss in ammeter, power loss in ammeter. Okay, power loss in ammeter. If I make this power loss in ammeter 0, then measured power will be equal to true power. Okay, so this is the error. This is the error due to ammeter. Power loss in ammeter is nothing but error due to ammeter. If RL is high, IL will be less, IL will be low. If IL is low means IL square RA will be less. Okay, so that you can decrease this error, right? Okay, so this VA method is suitable for the measurement of power in the circuit consisting of low resistance. This method is suitable for the measurement of power in the circuit consisting of high resistance. Okay. Now we'll move on to the next method. Second method is ammeter voltmeter method. That is AV method. In this method, first we connect ammeter, then after voltmeter. Let this is the voltage applied to the circuit. Let V is the voltage applied to the circuit. Let RL is the load resistance. Let IL is the current flowing to this. Let VL is the voltage across this load. Okay, now measured power that is PM, which is equal to voltmeter reading into ammeter reading. Okay, what is voltmeter reading? anyhow this reads voltage between these two points. Voltage between these two points is nothing but VL only. So VL. What it reads? What ammeter reads? Ammeter reads the current which is flowing through this as well as this current flowing through this. Let IB is the current flowing through this. Okay, then ammeter reads current flowing through voltmeter plus current flowing through load. Okay, then VL IL plus VL into IB. So which is equal to VL IL plus VL square by VL square by RV. VL square by RV. This is what this is measured value. Okay, this is what true value. So measured value is equal to true power plus power loss in voltmeter. Power loss in voltmeter. This is what, this is error. Error due to voltmeter. Okay. This method is suitable for the measurement of low resistive loads. Okay, if RL is low means power loss will be less. Okay, so this method is suitable for the measurement of low RL. This method is suitable for the measurement of power in the circuit consisting of low load resistance. Okay. Now here, in this case, the error is due to ammeter. In this method, the error is due to voltmeter, right? So, coming to the observation, the error is due to the instrument which is connected at load side. The error is due to the instrument which is connected at load side. Okay, error is due to voltmeter means this is the, this instrument is connected at load side. Okay, this instrument is connected at load side means you are going to get the error due to this instrument. So, the error is due to the instrument which is connected at load side. Now coming to power in AC circuits. Power in AC circuits. Normally we use RL load. Okay, now so let me use RL load, lagging load. We use lagging load. Okay, so let me use lagging load here. RL. Let V is the voltage. Vm sin omega t. Okay, I. Then I will be, as it is lagging load, I will be equal to Im sin of omega t minus phi, where phi is the phase angle between voltage and current. So coming to the wave diagram, if this is the voltage, then anyhow current lags voltage by an angle phi. Okay, let this is the phase angle phi. Start from here, waveform starts from here. Fine. Okay, coming to the instantaneous power, anyhow this is voltage, this is current. Coming to the instantaneous power, okay, this is instantaneous power. Okay, coming to average power, okay, let us derive first otherwise. Okay, so average power, P average. Okay, first what is instantaneous power? Instantaneous power, nothing but P is equal to V into I. Okay, which is equal to, otherwise small v into small I, you can also write like that. So Vm sin omega t, Im sin of omega t minus phi. Okay, this is what? This is instantaneous power. This is what? Instantaneous power. Coming to average power, I am not interested in instantaneous power, I am interested in average power as it indicates power consumption in the circuit. So, average power over one cycle. 1 by 2 pi integration from 0 to 2 pi Vm sin omega t Im sin of omega t minus phi d of omega t. Okay. So P average is equal to 1 by 2 pi integration from 0 to 2 pi Vm Im sin omega t sin of omega t minus phi d of omega t, which is equal to Vm Im by 4 pi, okay, integration from 0 to 2 pi 2 sin omega t sin of omega t minus phi d of omega t, which is equal to Vm Im by 4 pi integration from 0 to 2 pi 2 sin omega t sin of omega t minus phi. Okay, then 2 sin A sin B, nothing but cos of A minus B, then you are going to get cos phi minus cos of A plus B, cos of 2 omega t minus phi d of omega t, d of omega t. Okay, then which is equal to Vm Im by 4 pi, cos phi is constant, then cos phi integration from 0 to 2 pi d of omega t minus what is the integration of this? Integration of this is sine of 2 of omega t minus phi by 2 from 0 to 2 pi. Okay. Anyhow, if you solve this, then this becomes 0, this part becomes 0. Then you are going to get Vm Im by 4 pi cos phi into 2 pi. 2 pi. Then you are going to get Vm Im cos phi by 2. Okay, that is P average is equal to Vm Im by 2 cos phi, okay, which is equal to Vm by root 2 Im by root 2 cos phi, which is nothing but Vrms Irms cos phi. So finally the power in AC circuits is VI cos phi, where cos phi is the power factor, phi is the angle between voltage and current. Okay. Average power is nothing but power consumption in the circuit. Thank you.